Hello again. In this video, we're going to look at a method called completing the square as a way to solve quadratic equations. This is a super useful tool and it'll come in handy in all sorts of math topics later on. So let's get into it. When using the completing the square method, it gives us a way to make a perfect square in order to solve equations. So let's look just at the method first. Say we have something like this, 16x squared plus 16x. We want to know what can we add to this to make it equal to something squared. And we're given a formula. Now remember, in a quadratic equation we have ax squared plus bx plus c. Now our formula for completing the square is we take this b and we divide it by 2 and square it. And in doing that, it's going to give us a perfect square that we can then factor and solve an equation with. So in this case, our b is 16. So dividing by 2, we get 8, and squaring that, we get 64. So if we put 64 here, that's equal to x plus 8 squared. And if you want to go ahead and FOIL it out to convince yourself, you'll see that x plus 8 times x plus 8 does in fact equal x squared plus 16x plus 64. And so we're going to use this technique to solve quadratic equations. Now, one thing that is very important to remember is that as we're adding something to the left side in an equation, we have an equal sign. And that means we'll need to do the same thing to the right side in order to maintain that equality. So let's take a look at an example. X squared minus 2x minus 5 is equal to 0. Now, we want to use our complete the square method, so let's begin by moving the 5 to the other side. So it's going to give us x squared minus 2x is equal to 5. Now we're going to take our b here and complete the square. So negative 2 divided by 2 is negative 1, and squaring that gives us 1. So that'll give us x squared minus 2x plus 1 equals 5, and we have to add 1 over here, plus 1. Again, if you would like to FOIL it out to ensure that this is x minus 1 times x minus 1 does in fact equal x squared minus 2x plus 1. So as this is x minus 1 squared is equal to 6, we'll now use the other techniques that we've learned in solving quadratic equations. Namely, the square root property, remembering that we must have a plus or minus here, and that'll give us x minus 1 is equal to plus or minus the square root of 6. Adding 1 to both sides, we get x equals 1 plus or minus root 6, which will give us our two solutions to the quadratic equation, 1 plus root 6 and 1 minus root 6. And those are the solutions to our original equation, x squared minus 2x minus 5 is equal to 0. Now let's try another example. 2x squared plus 5x minus 3 is equal to 0. Again, let's move the 3 to the other side, and we have 2x squared plus 5x, adding 3 to both sides, is equal to 3. Now, we're going to need to divide everything by 2, so that our first term is just x squared. X squared plus 5 halves x is equal to 3 halves. now we're going to use our complete the square method, and our b here is now 5 halves. So you're going to do 5 halves divided by 2. Now remember that 2 is really 2 divided by 1. That's the same thing, and when we divide two fractions, that's the same as multiplying by the reciprocal, which is we just flip the numerator and denominator, and so that's going to give us 5/4, and then we want to square that, and that's going to give us 25/16. So we're going to add 25/16 to each side. X squared plus 5 halves x plus 25/16 is equal to 3 halves plus 25/16. Now, how do we figure out what is this perfect square? Well, it's really just this number. It's what it was before we squared it. So it's our b divided by 2 is what it's going to give us. So it's going to be x plus 5/4 squared. And over here I'm going to show you really quickly that that is in fact true. By foiling, we get x squared plus 5/4 x plus 5/4 x plus 25/16, and that's going to give us x squared plus 10/4 x plus 25/16, and as 2 is divisible by both of this, that's x squared plus 5 halves x plus 25/16. So you can see that this does in fact give us our original equation, and that again is just our b term divided by 2. Now to add the right side of the equation over here, we need to have like denominators, so we're going to multiply by 8/8, as that is the same as 1. We're going to get 24/16 plus 25/16, and that's going to give us 49/16. Now, using the square root property, we're going to take the square root of both sides, remembering that we must include both positive and negative values, and we'll have x plus 5/4 is equal to the square root of 49 is 7, the square root of 16 is 4, so we have plus or minus 7/4. And subtracting 5/4 from each side, we have x is equal to negative 5/4 plus or minus 7/4. And that will give us our two solutions, negative 5/4 plus 7/4 and negative 5/4 minus 7/4. Now adding these together, 7 minus 5 is 2/4, so that's 1/2. And this is negative 12/4, which is negative 3. So our solution is x is equal to 1/2 and x is equal to negative 3. Now let's go ahead and check that that is in fact a solution to our original equation, 2x squared plus 5x minus 3 equals 0. 2x squared plus 5x minus 3. Now, substituting in our first x is 1/2, 2 times 1/2 squared plus 5 times 1/2 minus 3 is going to give us 2/4 plus 5/2 minus 3, which is the same as 1/2 plus 5/2 minus 3, which is the same as 6/2 minus 3, and 6 divided by 2 is 3 minus 3, and that does in fact equal 0, so we can see it is a solution to our original quadratic equation, our original polynomial. Now let's try it with our negative 3. Negative 3 squared plus 5 times negative 3 minus 3. Well, negative 3 squared is 9, and 2 times 9 is 18, plus 5 times negative 3 is negative 15 minus 3, which gives us 18 minus 18, and we can see that again is 0, and we can confirm that these are both in fact solutions to our original quadratic equation. Thank you so much for watching. I hope that helped. The next video we're going to look at is using the quadratic formula to solve these types of equations, so I hope you check that out as well.